1. In section 1, we're going to learn how to solve systems of equations. You've learned how to solve systems of equations before. Usually they were 2 equations, right? In here, we're normally going to do 3 equations. All right, so the process by which we do this is called Gaussian elimination. It's named after a mathematician, physicist named Gauss. So what it is we take 3 equations with like x, y, z variables, okay? And we can convert them, that's called a linear system. We can convert them into what we call triangular form, or it's also called row echelon form. Okay, what does that mean? If you take your system of equations, so the systems of equations that we're going to be solving look like this, x, y, z, x, y, z, x, y, z. You do this Gaussian elimination process, and then look at what the equations transform into. One of them only has the variable z left, another one has y and z, another one has x, y, and z. So if you look, it's like a triangle, right? So that's why we call it triangular form. It's also called row echelon form. And we can do this using the equations like you've done in like algebra 1, algebra 2, whatever. But also you'll see that it's a lot more efficient if we do it using matrices. Okay? All right. So what's the process? So basically in here we had to eliminate one x term, and then here another x term and a y term, right? Those are the ones that needed to be eliminated. Now, there is more than one way to solve these, obviously, as always. Over the years, I've come up with an order that seems to be like the most efficient, so that's how I want to teach you guys how to do it today, all right? And my order, the way I do it is, I first eliminate the x term in equation 3. So this is the one that goes first. Then I eliminate the x term in equation 2. So that's the one that goes next. Last, I eliminate the y term in equation 3. So this one goes last, right? So it's 1, 2, 3. That's the order in which I eliminate them. And then at the end, we have to make sure that the leading coefficients of each equation are 1. Okay, so let's do one. Okay, we're going to solve the first one using the full equations. And then after that, we're going to do it using matrices. So here we go. So to solve this one, I need to get rid of these 3, basically, right? And we said the first one I want to get rid of is this one. Okay, so here's what you do. I like to draw, a little arrow like this, because now I'm going to change my equations. All right, this is the one I want to get rid of. That's the row that's going to change. These 2 rows are going to remain unchanged, so I copy them over. 2x plus 2y plus 3z equals 6. X plus 2y minus z equals negative 3. Okay, now for this. Okay, somehow I need to combine this blue x with one of the other x's in that column in some sort of combination so that the end result is 0. Okay? So I can add 2 things together, I can subtract 2 things from each other, I can multiply by one by something and add to another thing, right? But what I want you to do is just, if you're eliminating that x, just focus on its column. So any suggestions on how I can combine this one with another one and get a 0? What do you think, Adam?
Sorry, just looking for a package here.
Oh, what? So if we're going to do the second row minus the third row, we also want to have way of tracking what we're doing. So what I do is I say row 2 minus row 3. Okay? Row 2 minus row 3. But now what you're going to do is you're going to do that same operation to the x's, the y's, the z's, and the constants. Okay? So I start with the x's. If I'm going to do row 2 minus row 3, x minus x gives me a 0. Okay? Next, move over to the y's. 2y minus y, y, so positive y. Move on to the z's. Negative z minus z, negative 2z equals negative 3 minus 2, negative 5. Okay? Okay, when it's a 0, we obviously don't have to write the 0, so now it looks like that. Okay, next, we're going to go one more time. Okay, the next thing I want to get rid of is which one? The x over here. So I'll do that in red. The x over here. Okay, now, I'm over here. So if that's the one I'm going to change, the other two are going to remain unchanged, so I just copy them over. Y minus 2z equals negative 5. Okay, so what can I do? Okay, so this one, right, only look in its own column. You don't have much choice. Okay, you have to combine it with this one, right? How can we combine this x and this 2x so that we get 0? You might have to multiply by 1 by something.
Times negative 2.
Times negative 2 and add, right? So, yes, so I'm going to multiply this x by 2. Can't write. Oh. Okay, so you can also multiply by 2 and subtract. So that's what we're going to do. It's the same either way, same operation. So, once I get it back, okay. Okay, so I'm going to multiply this by 2 and subtract. So basically what is going to happen is row 1 minus 2 times row 2. Okay? And maybe we might need a little, piece of scratch paper to do this. Okay. So, row 1, that's 2x. So we're going to do row 1 minus 2 times row 2. Row 1 is 2x minus 2 times x. That gives you 0. So the 0 goes here. All right? You guys following? Now I'm going to...
Where did you get... Oh, wait.
So row 1...
multiply the whole thing, though, by...
We're going to do it one by one. We're going to do it one term by one term. So we just did the x.
Oh.
Now we're going to do the y. Row 1 is 2y minus 2 times 2y. What does that equal? So that's 4y. 2y minus 4y, negative 2y. So this will be negative 2y. Okay, next we're going to do the z's. So let's do the z's. Row 1 is what? 3z minus 2 times negative z. Okay, do you see how the negatives can get you into trouble, right? Yeah. 3z minus 2 times negative z. That's 3z plus 2z, 5z. So plus 5z. Okay? We're going to do many examples, okay? Next, which one are we on now? The constant. Row 2, okay, what's in row 1? 6 minus 2 times what's in row 2? Negative 3. 6 plus 6 is 12. Okay?
Does it get like more complicated than this? Like, are there gonna be 4 ever? Is this hard?
No, never 4. We're not going to do 4. There can be 4, but we're not going to do them with 4. So, in the beginning, it maybe, because it's new, it might feel uncomfortable. We're going to stick with it because this is Precalc, and this is what we do in Precalc. We're going to finish this example. We haven't even done one example. We're going to finish this example, and when we're done with this example, we're going to do another one. And when we're having trouble, you guys are going to email me, and we're going to work on it together, okay? All right. So if it's a 0, I don't need to write it. And what's the next one I want to change? I need to change. It's this y down here, okay? That y down there, because I want to get it into a triangle. So if that's the one I want to change, I do arrow. Whatever is not going to change gets copied over. So you see, that's what I was going to say. As you notice, the first one is not going to get changed much. Well, not at all, okay? Okay, so now, if I want to get rid of that, if I want to make that y 0, look at that, right, multiply it by 2 and then add them, right? So what I'm going to do is row 2 plus 2 times row 3. Okay? The reason why I like to write that is it reminds me every time what I'm doing. So when I go on my scratch paper, I write down like the recipe sort of, right? The formula right now is row 2 plus 2 times row 3. Okay, so let's do it all in one shot here. So for the first one, what do I have in row 2? Negative 2y plus 2 times y. That gives me 0. What's the next one over? Row 2, I have 5z plus 2 times what? Minus 2z equals, how much is that? 5 minus 4z, 1z. And then the constants, 12 minus 2 times negative 5, 12 plus 10, 22. Right? So what do I have? 0z, 22. Okay, so here I put down 0 plus z equals 22. No, you don't have to write the 0 ever. Oh, no. No, you're totally right. This should have been a plus. Sorry, thank you. See, that was the whole point of writing it down. So what, it is a 2 then, right? Who had said 2? It's 2. Thank you, guys. All right. See, that's what happens. You can't get sidetracked.
Oh, wait. Oh, because you don't do anything to the top. Oh, it's just the bottom.
To put it in true row echelon form, the first constant, the leading coefficient in each row, has to be a 1. All right? So to make this a 1, we have to divide through by 2. Okay, so what we're going to do is we're going to do row 1 divided by 2. We're almost done. So x plus y plus 3 over 2z equals 3. What are we going to divide the second one by? Maybe negative 2? Negative 2. So we get y minus 5 over 2z equals negative 6. And then this one is fine. Okay. Now, this is in row echelon form. Yay! We abbreviate REF like this, row echelon form.
Can you leave it up there for 1 second?
Usually on the test, I'll put like a square or a rectangle in which you have to write your matrix. I'm sorry. Yes.
Like x, y, z to be like 1.
the leading coefficient needs to be a 1 for a row echelon form. Okay, now, we did this first part. Now there is this part, then solve. Okay, here is the solving part. When you solve, you have to find what is x, what is y, what is z. Okay? Right.
Who came up with this?
So, okay guys, come on. I need to figure out the values of x, y, and z. We need to get numbers for all of them, right? So, we already know that z is 2. Now what we're going to do, that's row 3. We're going to use this with row 2 to figure out what y is, and then with row 1 to figure out what x is. Okay, this is a row echelon form. Great. Most of the time, row echelon form is going to have these fractions inside, which none of us like to use. The good thing is, when you're solving these, you can go back and use any of the steps in order to continue your solving. The best way to do it is this step. So use this step to solve. Okay, we're going to do row 3, row 2, row 1. Row 3 tells us z is 2. Okay. Row 2 tells us negative 2y plus 5z is 12. But negative 2y plus 5 times what is z? 2 equals 12. Negative 2y plus 10 equals 12. Minus 10, minus 10. Negative 2y equals 2. Y is negative 1. Okay, so look, this is like algebra 1. Okay, and now I go to row 1. Okay,
So you start with row
3, 2, 1. Always. You use this step and you go row 3, row 2, row 1. Row 1, copy it down. Okay, but now 2x plus 2 times negative 1 plus 3 times 2 equals 6. So 2x minus 2 plus 6 equals 6. 2x plus 4 equals 6. 2x is 2, x is 1. Okay? So this bottom part was basically algebra 1. Now that I have my x, y, and z, I can write my solution, x, y, and z. It has to be a coordinate point because what we're doing when we solve these is the following. I'll scroll back up in a minute. If you have an equation with 3 variables, it represents a plane. If you have like an equation with 2 variables, y equals x plus 2, it's a line. 3 variables, it's a plane. Here I have 3 planes, and we're trying to figure out where those 3 planes meet, right? And 3 planes can meet at one point, at a corner, right? Like at one point, that's the answer to this. So like if you take a look here, you see that wall? That's one plane. This wall is another plane. And the ceiling is another plane. And these 3 meet at that one corner over there, right? Those are the coordinates of where those 3 planes meet. That's why it's a coordinate point. Right? So what we noticed here, right, throughout this process was we weren't doing the math, but the only thing we were changing were the coefficients. The x, y, z's never really changed, but we had to like carry them over every single time, right? And they remain unchanged. So it's more efficient if we drop the variables and just work with the coefficients without the variables. All right? So that's what we're going to do next. We're going to create an augmented matrix. So look, here is a system of equations, okay? If you drop the variables and just take the coefficients and the constants, 5, -5, -5, 35, and put it here, right? And you do that for all of them. Now you have the same information here carried over into the matrix, but you don't have the unnecessary X, Y, Z to like bog you down with anything, right? So that's what we're going to use now. This is called an augmented matrix. And if you just take this part, it's a coefficient matrix, but we're not going to deal too much with that. So we're going to use an augmented matrix to do the same thing. And again, we're going to put the augmented matrix into row echelon form. So look at how a matrix looks in row echelon form. The main diagonal is all ones. Oh, yeah. Why do you know that? From, huh? Oh, yeah. Sorry. I forgot. I thought in like programming class because it's used there as well. Okay. So look, one's here, zero's underneath. Okay? One's here, zero's underneath. That's what a row echelon matrix is. Okay, so let's take a look and see if any of these are in row echelon form. Look at the first one.
None of them.
Well, this is the main diagonal.
Oh, but doesn't it have to be 3?
No, it doesn't have to be 3. It could be 2, 3, 5.
However many rows it is.
Right.
There has to be 0 under.
Right. This is in row echelon form.
Why is there the dotted line?
The dotted line is where the answer is, where the constants go. Okay. Is this one in row echelon form?
No.
No. What about this one?
Yes. No.
Okay, this one is, because this is the main diagonal. Underneath the main diagonal is 0, and you're allowed to have a row full of zeros. Okay? Okay. Okay, so we're going to do the same thing. And again, we're going to do the same order as before. We're going to start with the bottom left, then the one right above, and then to the right. So same order as before. Okay? All right. Take a look at this one. So we're going to solve this matrix, the one that was over there, using row echelon form. Okay, now, look at your equations. Do you see how the first one can be divided through by 5? Let's do that first. If you can, always do that. Yeah. Okay? So that becomes x minus y minus z equals 7. No, you don't have to. It's we are. I'm just writing it over because we divide it through by 5. I didn't want to like skip too many steps, but you don't have to do this step on like if you're doing it on your own. Huh? Okay, so this is a very, very like intermediate step. I'm just getting rid of the 5s. We're going to start officially solving the problem right now. Okay? So all I did here is divide through by 5. Now I'm going to put this into an augmented matrix form. Here's how that looks. The first row gives me 1, -1, -1, 7. -1, 2, -3, -12. Yeah, I do that at the end. Okay, this is the matrix. Okay, you can do a dashed line, but it's kind of annoying to do a dashed line. It's also fine if you just do a solid line. Either works. Sorry, I was answering a question while I was doing it. Okay? Okay, at this step, always make sure, like double check to make sure you've copied the coefficients correctly, because it could create issues from the beginning. Okay. The process is going to be the same. The first thing we're going to change is this one. That means the other rows will remain unchanged, so I can copy them over. Okay? Okay, so again, just look in this column. So what we can do, right, if I multiply this one by 3, I can add it to this, right? It'll be negative 3 plus 3, it'll be a 0, right? So let's do that. So let's do 3 row 2 plus row 3. They do. That's why I copied them over. The only one I'm going to change is this one. When I multiply this by 3, I'm not going to like change it. Remember, I just do it like on my paper.
Oh.
Yeah.
Is the goal to get 1 in the bottom line?
0. Okay, so when we do that, we get 0. Now, we're going to do the same thing. I'm going to use this as my scratch paper. So 3R2 plus R3. So here, 3 times this is 6. 3 times 2 plus negative 2, 4. Again, if you can do this mentally, it's fine. You don't have to write it down. I'm just writing it down for people to be able to follow. Okay, now we're on to this column. 3 times this plus 7, negative 9 plus 7 is 2. Yeah.
Negative 2. How did you get the equation?
So 3 times negative 12 is going to be negative 36 plus 30, negative 6. What do you mean by combine? No. No, these are like, you can't mix. No. Okay. So now, the next thing we're going to do is we're going to get rid of this one. Okay? So these 2 rows are going to be unchanged. So I'm going to get rid of this negative 1. Let me do this. Okay. Now look. This first row will be unchanged. The second row will also be unchanged. But as you're copying it down, we can also work smart, not hard for the next time, right? Do you see how all of these can be divisible by 2? As you copy it over, you can do that just so you can have smaller numbers to work with. So instead of putting in 0, 4, negative 2, negative 6, what else can I put in? Right. 0, 2, minus 1, minus 3. It's, I suggest you do just so you have smaller numbers to deal with, but you don't have to. In the case of matrices, we have to keep the 0 there. You can't just eliminate it. Okay, let me do a little bit more, then I'll take questions.
Where did you get the negative 36?
3 times R2 here. That's why I write them. So 3R2, 3 times negative 12 is negative 36. That's why I write down all my steps so you guys can follow. Okay, so next one here. So if you look in this column, how can you combine to get a 0 for that circled one? Yeah. R2 plus R3. 0, 1, negative 4, negative. I'm sorry. R2 plus R1. Same thing, yeah. That one was easier to change, okay? Okay, so we're almost there. The only other thing left is that 2. Okay, so I'm going to erase my scratch work here. Yeah. So the only thing else is this one. Okay, so for this, now listen, this is the benefit why I do it this way, in this order. You see how you have zeros for these 2 here? When you're going to change that green 2, we're only going to combine it with the row above. Because if you combine this with row 1, then you undo the 0 here. So once you get to this point, always combine row 2 and row 3. So at this point, whoops, let me write that down. At this point, only use row 2 and row 3. Okay, so To use row 2 and row 3, I'm going to multiply this by 2 and subtract this. So let me write that down. First, let's write down the ones that aren't changing. Okay? And I'm going to take your question in a second. Just give me 1 second. Row 2 minus row 3. Okay? So I'm going to make this a 0. Multiply this by 2 minus this. This minus this. So I get 0, 0. Okay, let's see if we can do this without, maybe let's see if we can do this mentally. This times 2 is what? Negative 8 minus negative 1. Negative 7. Okay, so negative 8 minus negative 1. Okay? Next one, negative 10 minus negative 3, negative 7.
Where'd you get
Okay, for the next one. Yeah, let me finish this and then. Okay, now we're almost at row echelon form. This one actually worked out rather well because these are already 1s. Now I just have to make this a 1. I can divide both by what? Negative 7. So 1 minus 1 minus 1, 7. 0, 1, negative 4, negative 5. 0, 0, 1, 1. And the way we write that is, we did row 3 minus negative 7. This is in row echelon form. And look, this time we don't even have fractions in row echelon form. So I can use that to to solve it. Okay. Let me quickly solve this because we're running out of time. So take a look at what we have here. This is the X group, the Y group, and the Z group. Okay? So, for each one of these, take the first row. 1x minus 1y minus 1z equals 7. This last one, 0x, 0y, 1z equals 1. So from row 3, I have z equals 1. What do I have in row 2? 1y minus what? Minus 4z equals negative 5. So y minus 4 times 1 equals negative 5. Y equals negative 1. Okay, what do I get from row 1? X minus y minus z equals 7. So, x minus negative 1 minus 1 equals 7. X plus 1 minus 1 equals 7, so x is 7. So how do I write my answer? 7, negative 1, 1. Okay.